Okay, here we're writing piecewise functions. So you're going to be given the graph, and your mission is to come up with the equation. Okay. These are all going to be linear pieces of our piecewise function, so you don't have to figure out what the equation of like a quadratic is from a graph. Although I bet you could do that if I really needed you to. So we'll make this note. These are linear functions, meaning they follow a y equals mx plus b equation, and you guys don't need to be reminded this, but just to be clear, m is the slope of the line and b is the y-intercept. Okay, and notice like this one does not have a y-intercept. Actually, none of them do, right? So you can tackle that a couple of ways. You can either kind of extend the line in your head to see where it crosses. So this one has a b of 8, or you can plug in a point into your equation, but I think it's easier to just check it graphically. I think they should all be integers, meaning whole numbers, so you shouldn't have any decimals you run into here. The major note you need to note is make sure you pay attention to the boundaries. So that's open versus closed circle. Those mean the same as they did before. So we will say that closed circle means you're going to use greater than or equal to. Open circle means strictly greater than or strictly less than. Okay. So we are stating the regions where our equations apply, and we are writing down the equations of each line. Okay, so for this guy, looks like we go up 1 over 1, up 1 over 1. So rise over run, we have a slope of 1, right? And we have a y-intercept of 8. So I'd say my equation is 1x, and really you don't have to write the 1, right? 1x plus 8. And then my region, well, this is every x less than -4. So I'm going to highlight it on the x-axis so you can see it. And also x equals -4. Okay. So closed circle gets a line, right? X is greater than or equal to -4. So that describes the left-hand piece, and I'll switch colors for the right-hand piece. The right-hand piece looks like it has a y-intercept of 4 and a slope of, let's see, up 1 to the right 3, 1 over 3. Okay, so I would say 1/3 x plus 4, and then here looks like we go from -3, and we have an open circle this time, to infinity, so I'd say x strictly greater than -3. Okay. So there's your example. Again, you're just writing down the equation of the lines, which you should definitely know how to do at this point in your math career. And then you are writing down the regions where the lines live. So that's the second part. It's where the lines live. And these are their equations. And that's it, really. I'll show you one additional example because I want to show one situation that you can run into that you may be less familiar with. But I think you would agree that the two pieces separately you're already good at, and we're just putting them together here. Okay, so there's two somewhat interesting situations you can run into here. The first is we have a horizontal line. So this line has a slope of 0 and a y-intercept, it looks like, of 5, right? So horizontal lines, you probably recall, have just an equation of like y equals, in this case, 5, right? Because that's where we see it. So that's the first thing you can run into is you can have a horizontal line. The bound works the same, right? So for the region x less than or equal to -4, because we have a closed circle there, right? And then my second piece, it looks like I have a slope of 2. I'll switch colors here. Slope of 2 meaning I'm going up 2 over 1. And if I continue that down here, I have a y-intercept of 2. So if my slope is 2 and my b is 2, my equation is 2x plus 2. For x, well, x is greater than 2, it's to the right of 2, and I'm going to leave it as just plain old greater than because I have an open circle there. So horizontal line works just like you remember it. And my last one, I'm going to show you actually in Delta Math, because I want to show you how to add an additional piece. So notice I have three things I have to contend with here. I have my horizontal line, and then my diagonal line, and then this dot up here, this point that's not on either of those lines. So I'm going to start with the horizontal line. That's just a horizontal line through y equals -5. And then I'll say for x less than 2, it looks like, right? And then my second piece is my dot. So I'll say that's at y equals 6, f of x equals 6. And that's for x equals 2. And then we'll add one more rule. I click that add rule button. And here we're going to say, well, we need the equation of the line. So it looks like my slope is -3/2. And I just counted rise over run, so I'm going down 3 to the right 2. So -3/2 x. And then my y-intercept, well, would be -2 if I follow that line up. And this is going to be for x greater than, oops, that's the same thing, greater than 2. Okay, so the point, we use an equal sign, and that's something you maybe are less familiar with. Okay, that's all there is to it. So you can get piecewise functions with up to 3 pieces here.